These types of languages were also built upon Lisp, mainly originally on the Lisp machines, such as ICAD. Then there are many frame languages such as KL1. In the 1990s, fifth generation languages were considered to be the wave of the future, and some predicted that they would replace all other languages for system development, with the exception of low-level languages. Most notably, from 1982 to 1993, Japan put much research and money into their fifth generation computer system project, hoping to design a massive computer network of machines using these tools. Today, fifth generation languages are back as a possible level of computer language. A number of software vendors currently claim that their software meets the visual programming requirement of 5GL concepts. Criteria in a good language design. Writability. The quality of a language that enables a programmer to use it to express a computation clearly, correctly, concisely, and quickly. Readability. The quality of a language that enables a programmer to understand and comprehend the nature of a computation easily and accurately. Orthogonality. The quality of a language that features provide have as few restrictions as possible and be combinable in many meaningful way. Maintainability. The quality of a language that eases errors can be found and corrected and new features added. Generality. The quality of a language that avoids special cases in the availability or use of construct and by combining closely related constructs into a single more general one. Uniformity. The quality of language that similar features should look similar and behave similar. Extensibility. The quality of language that provides some general mechanism for the user to add new construct to a language. Standability. The quality of language that allows programs written to be transported from one computer to another without significant change in language structure. Implementability. The quality of a language that provides a translator or interpreter can be written. This can address the complexity of the language definition.
Basic fundamental concepts in programming languages. Any discussion on the foundations of computing runs into server problems right at the start. The difficulty is that although we all use words such as name, value, program, expression, or command which we think we understand, it often turns out on closer investigation that in point of fact we all mean different things by these words, so that communication is at best pres- these misunderstandings arise in at least two ways. The first is straightforwardly incorrect or muddled thinking. An investigation of the meanings of these basic terms is undoubtedly an exercise in mathematical logic and neither to the taste nor within the field of competition of many people who work on programming languages. Basic concepts. Assignment commands. One of the characteristic features of computers is that they have a store into which it is possible to put information and from which it can subsequently be recovered. Furthermore, the act of inserting an item into the store erases whatever was in that particular area of the store before. In other words, the process is one of overwriting. This leads to the assignment command, which is a prominent feature of most programming languages. Assignment commands. The simplest form of assignments, such as L values and R values. An L value represents an area of the store of the computer. We call this a location rather than an address in order to avoid confusion with the normal store addressing mechanism of the computer. There is no reason why a location should be exactly one machine word in size. The objects discussed in programming languages may be like complex or multiple precision numbers more than one word long or like characters less. Some locations are addressable but some are not. Before we can decide what sort of representation a general non-addressable location should have, we should consider what properties we require of it.